Hello everyone, Mr. Fawcett here, and we are back for part 2 of our geometric proofs lesson. Last video we didn't actually get into any proofs. We spent most of the time just going through the different properties, the definitions, the theorems, the postulates that you're going to use to justify each statement in your geometric proofs. And you can kind of add those to the basket of properties that we talked about for our algebraic proofs lesson, subtraction property of equality, addition property of equality, etc. But today we are going to apply that. We have plenty of proofs to do. So we're going to start at the second page. Now you'll notice today I have given you the statements, or at least I've given you one of each column for whatever row you're working at or working on. As we move into later lessons, you will start to write full proofs on your own. But again, we're kind of working our way in here. So you're kind of like filling in a puzzle today, whereas as we move forward into future lessons, you'll be building the entire puzzle on your own. So I would encourage you to just work through, you could try all the proofs, or you could try one proof and then watch a video, then try the next proof, watch a video of that proof, etc. That may actually be the best, going one by one. But definitely try the proofs on your own. Read through those properties. It's going to take you a while before you really know them inside and out. So before you just say, I don't know, and you just click play, read through them. Think about which one matches the statement to the left. Okay, so let's start with this first one. We say that angle A, actually, let's look at what we're given. It's always a good thing to check out your given before you just jump right into the proof. So we have a diagram, and we have some words. So it says angle A and angle B are complementary, and angle A is congruent to angle C. And we're being asked to prove that B and C are complementary. So if you want to, you could fill in some arcs on your diagram. We know that A is congruent to C, so we could put two little arcs at A and C, just to let us know that those two angles are congruent. Now, the first statement I already wrote down. I just wrote down the given, right? We have to start somewhere, and it's generally a good idea to start with the information that's already provided to you. The next statement says the measurement of angle A plus the measurement of angle B equals 90 degrees. So where did that come from? Well, it comes from something from our given. It says that angle A and angle B are complementary. So we know that the measurements of those two angles sum to 90 from the definition of complementary angles. You can do one of two things. A lot of times I just abbreviate angles with the little angle sign and an S. If you want to write out the word angles, that's also okay. Let's make sure we have an M there, so complementary angles. As we go to our next statement, it says the measurement of angle A equals the measurement of angle C. Well, how do I know that the two measurements of those angles are equal to one another? Well, again, it comes from the given. We are told that angle A is congruent to angle C. So by the definition of congruent angles, we know that their measurements are equal. So definition of congruent angles. You'll notice I do a lot of abbreviating. Again, you can use the congruent symbol for the word congruent if you want, and then I also use the angle symbol for the word angle. So definition of congruent angles. You can also write those words out, not a problem either way. If we were writing up this proof for a paper or something that we were going to present to somebody, then you would definitely want to just write out the words. It looks a bit nicer. Next statement. So we have the measurement of angle C plus the measurement of angle B equals 90. Where did that equation come from, right? Well, let's look at what we have up here. We have these two equations. Is there a way to create this third one from those two? We have A plus B equals 90, and we have A equals C, so C plus B equals 90. Well, we're doing some substitution. We're taking this right here and swapping it in for the measurement of angle A because the measurement of angle C equals the measurement of angle A. So substitution property of equality. When we are doing substitution with equal signs, we use the property of equality. As you'll see later on, if we do substitution with congruency symbols, then we will do the POC, the property of congruence, rather than the POE. All right, let's look at our last statement. B and C, those two angles are complementary. Well, how do we know that? Why are we able to write that? Well, if we know that their measurements sum to 90, then the definition of complementary says that those angles will be complementary. So definition of complementary angles. You'll notice that this definition works both ways. You can either use it to say that the two angles that are complementary equal 90 degrees, or you can use it to say two angles that equal 90 degrees, the sum of their angles equals 90, that those two angles are complementary. All right, let's move on. All right, again, pause the video, see if you can fill in the reasons for this proof, and then we will work through it together. Okay, so let's look at what we're given. It says B is the midpoint of segment AC, and segment AB is congruent to segment EF. So a couple things we could fill in here on our diagram. If we know that B is the midpoint of AC, then we know that these two segments have the same length. So we could put two little tick marks there. Those segments are also going to be congruent. And we know that AB is congruent to EF. So if AB has one tick mark, then EF could also have one tick mark. Then we need to prove that BC is congruent to EF. Well, based on our diagram, we see that BC and EF have one tick mark each, which means that they are congruent. But we have to walk through the formal process of showing that. Even though it looks like it is from the diagram based on what the tick marks we filled in, we still have to go through each step. So we're going to start off. The first statement is just the given information. The second statement says the length of AB, so when I leave the bar off, we're talking about the length of AB is equal to the length of BC. Well, where did that come from? How do we know that AB has the same length of BC? What in our given, so let's take a look up here, because this is the only information we have to work with right now. What part of our given tells us that AB equals BC? Well, it's the fact that B is the midpoint. If B is the midpoint, then we know that each piece or each half of that segment is half of the whole segment, or they are both equal to one another. So this second statement is the definition of midpoint. Okay, next statement says segment AB is congruent to segment BC. So we go from having equal segments to congruent segments, and that is just by the definition of congruent segments. Remember, that allows you to go from two segments being equal to two segments being congruent, or the opposite way, two segments being congruent to two segments being equal. Now, the last statement says BC is congruent to EF. So how do we work with, we have this congruency statement, oops, let me get my pen. We have this congruency statement, and we have this one. Is there something we could do with both of those to get this one down here? Well, you could say one of two things. Notice that AB is congruent to both EF and BC, right? Which means that EF and BC have to be congruent to each other. That would be the transitive property. transitive property of congruence, so POC. Now, if you look back to our algebraic properties from lesson 2.5, I believe, we talked about the transitive property being a very specific type of substitution, right? So you could look at this as a substitution problem, and what they're doing is they are swapping BC, still on my eraser, they're swapping segment BC in for segment AB to get this segment down here. Right, so you could say transitive property of congruence. That is the best answer. The other acceptable answer would be substitution property of congruence. So either one of those is acceptable. Preferable, though, for you to use the orange, the transitive property of congruence. All right, on to the next one. Nice short proof here. Just two reasons. So take a look, see if you can figure out what those two are, and then click play. Okay, so this time our given, there's nothing written down. It just says see the diagram. So, you know, there's nothing direct that we can put in our statements column that's given. So we're going to have to come up with something else based on what the diagram gives us. The first statement I gave you, it says measurement of angle 1 plus a measurement of angle 2 is equal to 180. Well, if we come over here to the diagram, how do we know that the measurement of angle 1 plus the measurement of angle 2 equals 180? Is there a relationship between both of those angles? Well, they both form a straight line, which makes them a linear pair. They're adjacent angles that form a straight line. And linear pairs, the sum of those angle measurements add to 180. So this is the linear pair theorem. Linear pair theorem says if you have two angles that are a linear pair, their measurements will sum to 180 degrees. And then I think the next statements, or the next reason, is a little easier. If I know that those two angle measurements sum to 180, well, how do I know that they're supplementary? Well, that's just the definition of supplementary angles. Definition of supplementary angles. Nice short two-line proof. We have two more. We should be able to get through both of them. All right, so I squeeze all this in. Yes, I can. Okay. So pause the video, come back when you're ready. We are given that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, and we need to prove that angle 1 is congruent to angle 3. So let's look at the first statement. The first statement's blank, but you know that the reason is given. So I'm not going to write this all down, but what you should have on your paper, you should put all of this in the first statements box. You do need to write it in there. I'm just not going to write it in there just because it's harder to squeeze everything in with the marker feature that I'm using. But you would need to put all of that in the given. Okay, the next statement says the measurement of angle 1 plus a measurement of angle 2 equals 180. Well, how do we know that? Is there something from the given? Is there something from this given up here that tells us angle 1 and angle 2, their measurements sum to 180? Well, it tells us that angle 1 and angle 2 are supplementary, right? It tells us that right here, so we can use the definition of supplementary. Okay. I don't give you the next statement, but I do give you the next reason. The next reason is also the definition of supplementary angles. So are there any other two angles that we could write an equation for? And if we come back up here, we notice that this part of the given hasn't been used yet. So we can say the measurement of angle 2 plus the measurement of angle 3 is equal to 180 because they're supplementary. Now, the next equation, we've done something, we've sort of combined these two right here. There's an algebraic property we're looking for because I have angle 1 plus angle 2 equals 180, and then 2 plus 3 equals 180. Then I come down here and it says 1 plus 2 equals 2 plus 3. The angle measurements, that is. So notice that 180 is equal to both of these expressions. Whenever something is equal to two other things, or when two things are equal to the same thing, we can say that those things are equal to one another by the transitive property. And in this case, the transitive property of equality, because we have equal signs. Transitive property of equality. You're not given the next statement, but we are given that we are using the subtraction property of equality. And it might help to see what we're trying to end with. So I'm trying to end with angle 1 on one side and angle 3 on the other side. So what would I subtract from both sides to make that happen? Well, I would want to subtract the measurement of angle 2 from both sides. If I subtract the measurement of angle 2 from both sides, I'm left with the measurement of angle 1 equals the measurement of angle 3, using the subtraction property of equality. And then I'm just converting. I'm converting from an equals statement to a congruency statement, right? Or an equation to a congruency statement. So that is just going to be the definition of, in this case, it's congruent angles. So the definition of congruent angles. Okay, let's look at one more, then we will end the video. Okay, we are told that, and again, pause it, of course, before you come back and watch it, so you have a chance to attempt it yourself. Here we are given that angle 2 is congruent to angle 3. Notice that they already give you the tick marks on your diagram, so you don't have to put them there again. And then we are trying to prove that angle 1 and angle 3 are supplementary. So let's look at our statements. Angle 2 is congruent to angle 3. Well, that was a given. If I know that those two angles are congruent, they must have the same measurement, right, by the definition of congruent angles. You see we've been using that quite a bit. And then we seem to have something new. So it says the measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. So if we look at our first two statements, because we can only work with what we've come up with, right, or what we're given. So if we look at these two statements, keep getting my eraser, there we go. Is there any way we can go from those two to this equation right here? Well, I don't see any 180 anywhere, so it seems unlikely. That only leaves us with the diagram. So is there something from the diagram that we haven't used yet? Anything from the diagram that says measurement of angle 1 plus measurement of angle 2 should equal 180? Well, these two angles right here, they form a straight line, which means they're a linear pair. And linear pairs, their measurements sum to 180. So we have the linear pair theorem again. So sometimes you need to look back at what you've done in the proof prior, and then sometimes you may need to go back and check the diagram, right? Those are your two options for where new information can come from. It can come from what you've already done in the proof or the figure or diagram that you're given. Okay, so now I have a statement that says angle 1 plus angle 2, those measurements equal 180. So is there a way I can combine any of these three statements to get this one right here? Well, I have one that's pretty close. I have this one, but I need to get rid of that measurement of angle 2. Well, measurement of angle 2 equals the measurement of angle 3, so I can make a little substitution. Substitution property of equality. And my last statement, if I know that these two angles sum to 180 degrees, then they must be supplementary by the definition of supplementary angles. Okay, this brings us to the end of the proofs for this lesson. We're going to continue to do more proofs not only throughout this unit, but throughout the rest of the course. And these properties that you're using, think of them like a toolbox. So we're slowly adding more and more tools to our toolbox so that we can complete more and more complicated proofs. So I encourage you to really try to understand and get these properties down so that when we learn new properties, you don't have to go back and try to worry about these, right? They'll just be like vocab words, old vocab words that you learned years ago, right? That's how you want to treat these. The more you use them, the more they become familiar, and the less you have to think about them. Okay, as always, enjoy the rest of your day, and I look forward to seeing you next time.